Welcome back, everybody, to the deep dive. And today we are going, really small, like microscopic. We're going to be talking all about nanotechnology.
Oh, yeah. The world of manipulating stuff at the absolute tiniest level, it's invisible to us practically.
Right. We're talking about a scale of like 1 to 100 nanometers. That's
Yeah.
crazy small. A billionth of a meter. I was thinking about this earlier, like a human hair compared to these things is like a redwood tree.
Yeah.
Huge.
Oh, yeah. Absolutely massive. It's wild to think about.
It really is. So we have this really cool PDF today to guide our deep dive. It's by uh, Jörg-Owe, and it's simply titled Nanotechnology.
Yep. It covers a ton from like the super basics all the way to like, whoa, mind-blowing applications. Even gets into some of the ethical questions that come up.
Yeah, there's a lot to unpack for sure. So let's start at the beginning, right? Like, how do we even make these nanomaterials? Schneepat talks about these two approaches, right?
Mm-hmm.
Top down and bottom up.
Yeah. It's almost like, think about sculpting like a statue versus building something with Legos, right? Top down is like taking a chunk of something and just smashing it down till it's nano size. Like take a rock and just keep hitting it till you get super fine sand.
Okay. That's top down. But
Yep.
bottom up sounds a little more, I don't know, elegant.
Yeah, it is. It's more like you're assembling atoms and molecules like building blocks. So kind of carefully placing each Lego brick until you have exactly the structure you want.
Schneepat mentions chemical vapor deposition
Oh, CVD,
as
right.
one of the methods for bottom up.
So like brute force versus like real precision engineering. Fascinating. Now, Schneepat talks a lot about these carbon nanotubes. They seem to be all the rage in the nano world. What makes them so special?
They are really cool. Like, imagine something stronger than steel, but like lighter than air.
Stronger than steel. Yeah. And CVD, chemical vapor deposition, that's one of the main ways we make them, actually. But what's even more fascinating is that how you make a nanomaterial, like top down versus bottom up, it actually affects its properties.
Whoa, hold on. So the same material, but just made differently, can act totally differently.
Exactly. That's the crazy thing about nanotech. We're not just shrinking stuff. We're like changing them at the atomic level so they behave differently. It's like we're unlocking this whole hidden world of possibilities.
I'm definitely intrigued. But okay, why bother? I mean, what makes nanomaterials so special, so different? Schneepat has this whole section on their properties.
Okay.
And it's like things get weird, like quantum dots that change color based on their size. What?
Yeah. It's mind-blowing. You're talking about these teeny tiny crystals, and just by growing a little bigger, they shift from like red to blue.
Yeah.
And it's because of something called quantum effects.
Quantum effects. No, that sounds a little intimidating, I'm not going to lie.
No, it's actually super cool. Think about it like this. At the nanoscale, how light interacts with matter changes completely. The size of the quantum dot, it actually determines the energy levels of its electrons. And those determine what colors of light it absorbs and emits.
Okay, so it's kind of like a mood ring, but instead of, magic and whatever, it's actual hardcore physics. I love it. That's incredible.
Right. And then there's the fact that nanomaterials have this like crazy high surface area compared to their volume. Like think of crumpling up a piece of paper, same amount of paper, but now you have way more surface exposed, right?
Yeah, I see where you're going with this. More surface means more atoms are available to interact with their surroundings, so they become more dot reactive.
Exactly. They can like speed up chemical reactions or act as tiny sponges for like pollutants. They can even deliver drugs super precisely to specific cells in the body. That's why Schneepat says they have the potential to like revolutionize so many fields.
So it's not just about things being smaller. It's about them being smarter and more powerful. This is starting to sound like we're talking about like superpowers here.
In a way, yeah. But we do need to be careful, right? Like Schneepat points out, this kind of power, well, it comes with responsibility.
Okay, responsibility. That sounds kind of, I don't know, ominous. Are we talking like ethical dilemmas here? Or are there actual risks with this nanotechnology stuff?
Well, to be honest, both. But I think it's worth starting with some of the cool applications first. Schneepat really dives deep into how nanomaterials could, like, revolutionize different fields. Like, one of the most promising areas is energy storage.
Oh, now that's something I'm interested in. Imagine like your phone battery lasting an entire week on just one charge.
Yeah.
No more like frantically searching for a charger.
Yeah, it'd be amazing. But it's not just about, like, convenience, right? Better energy storage would be huge for electric vehicles, for renewable energy, I mean, even for entire power grids.
Hold on. How do these like tiny particles actually make a battery better? Like, does Schneppbeck give any specifics?
He does. Remember how we were talking about that high surface area thing with nanomaterials?
Yeah.
Well, that's a big deal here. Schneppot mentions this. Linino 0.80.202.
Okay.
They're these tiny spherical particles used in some lithium-ion batteries. And their size and shape, it gives them so much surface area, and that means more spots for those electrochemical reactions to happen.
No, more surface area basically equals more power. Like, it's like having a bigger engine, but in a smaller car.
Exactly. And then there are those carbon nanotubes we talked about, those super strong, super lightweight ones.
Yeah.
Schneppert says you can use them to make electrodes without needing those binders.
Binders.
Yeah, those things that are typically used to, like, hold the active materials in the battery together.
Oh, right.
But the thing is, binders can actually make a battery worse, They take up space, they add weight, which means you can't store as much energy. But with carbon nanotubes, you can create these, like, super thin, porous electrodes. Way more efficient.
So it's like getting rid of all the dead weight in the battery.
Yeah,
Yeah.
exactly. And Schneppert points out how these binderless electrodes, they actually do better than those conventional graphite anodes, the ones we use now.
So longer lasting batteries, more powerful batteries.
Yep, all thanks to these tiny little tubes.
Man, that is so cool. Okay, I'm sold on nanotech for batteries. But I remember Schneppert also mentions this thing about like water splitting and hydrogen production. What's that all about?
This is where it gets even more futuristic. We're talking about making clean energy from water.
What?
Yeah. Nanomaterials can act as catalysts.
Catalysts?
Substances that speed up chemical reactions. So in this case, they can help split water molecules into hydrogen and oxygen.
So not just better batteries, but potentially a whole new source of clean energy. That's mind-blowing.
Yeah, it has huge potential.
But how efficient is it really?
Well, that's the tricky part. Splitting water, it takes energy to do that, and right now the process, it's not as efficient as we'd like it to be. But Schneppert, he seems to think that nanomaterials could be the key, to improving the efficiency and making this whole hydrogen production from water thing like a real viable source of clean energy.
That would be revolutionary.
Yeah.
It's like straight out of sci-fi.
Yeah.
And I remember Schneppert also talking about this environmental remediation thing. Is that like tiny robots cleaning up pollution?
Maybe not robots in the, the traditional sense, but the idea isn't that far off. It's about using nanomaterials to remove contaminants from, like, water and soil. Like, imagine these tiny sponges soaking up all the bad stuff.
Wow. So we could clean up the messes we've made using nanotech.
Exactly. He even mentions this example, modified mesoporous carbon. It's been shown to be incredibly good at getting rid of mercury from water. Like, super effective.
But there's got to be a catch, right? It all sounds a little too good to be true.
Well, the main challenge is making sure these nanomaterials themselves don't become a problem, Like, they need to be biodegradable, or we have to be able to safely remove them after they've done their job. Schneppert's really big on this. We need a ton of research, a lot of testing to make sure we're not just, like, trading one problem for another.
Makes sense. Got to be responsible with this stuff, right?
Yeah.
What else is Schneppert excited about?
He talks a lot about this idea of targeted drug delivery.
Oh, yeah.
Which is super cool. Imagine medicine going exactly where it needs to go in your body with way fewer side effects.
Mm-hmm.
He specifically mentions carbon quantum dots. Those tiny crystals we talked about that can emit light.
Oh, yeah, the mood ring things?
Exactly. Mm-hmm. He thinks they could be used as, like, these tiny little nanocarriers for drugs.
Oh, so we're talking super precise medicine, like right to the source.
Yeah. He says this could be huge for treating diseases like cancer, where you really want to target those tumor cells without harming any of the healthy tissue.
Man, this is all incredible. But I got to be honest, I'm still a little, I don't know, wary. Like, we're talking about messing with stuff at the atomic level. What could possibly go wrong?
Well, you're right to be cautious. Like any really powerful technology, there are potential risks, and Schneppert definitely doesn't shy away from that.
All right, so let's talk about this dark side of nanotech then.
Mm-hmm.
What are the risks? I mean, what could go wrong when we start messing with stuff at the atomic level like that?
Well, one of the biggest things Schneppert brings up is, the health risks. These engineered nanomaterials, these ENMs, they're so tiny, like they can slip past our body's normal defenses and get into our cells. And we don't totally understand how they might interact with our bodies yet.
Okay, yeah, that's a little freaky. Like, what kind of health problems are we talking about?
Well, Schneeplot talks about some studies, right? And they've shown that certain E&Ms, they can cause inflammation and damage in the lungs, kind of like what we see with asbestos. And there's even concern that some of these E&Ms, they could potentially damage DNA.
DNA damage. That's serious. We're talking about cancer risks here, right?
That's one of the big worries. And even those carbon nanotubes, remember?
Yeah, yeah, those amazing, super strong ones.
Well, there's research suggesting those might be a problem too. Some studies show they could act similar to asbestos fibers, leading to lung issues down the line.
Wow, so even the good ones, they can have a dark side. This is starting to feel like a sci-fi horror movie or something.
Right. It's important to remember we're still early on in all this. We need a lot more research to figure out like what the risks really are and how to make things safer. Pat's really big on this point, like proceed with caution. We need to study this stuff carefully.
Yeah, that makes sense. It's like we got this amazing new tool, right, but we're still trying to figure out like how to use it safely.
So I know Schneppat also goes into some of the ethical stuff, like especially with nanomedicine. What are the concerns there? Yeah, nanomedicine, I mean, it could totally change healthcare, right? But it also brings up these like really big ethical questions. Like Schneppat talks about informed consent, for example. What happens if the data collected from like nanosensors or devices implanted in your body, that data is used to train AI, but without you knowing?
Whoa, hold on.
Yeah.
Like my medical data being used to train AI without my permission, that's not just a privacy thing. It feels like, I don't know, wrong. Is Schneppat saying this is already happening?
No, not necessarily, but he's pointing out that it could happen. As nanotech gets more advanced, we have to really think about like who has access to all this info and how it's being used. We need some clear rules, some regulations.
Yeah, it's like the Wild West out there. Someone needs to lay down the law before things get out of control.
Yeah.
I mean, data privacy is a big deal these days with all this new technology, not just nanotech, right?
Oh, absolutely. And it's not just about privacy. It's about like what it means for society as a whole. Imagine a world where nanotech makes it possible to like constantly track people, but at a microscopic level. Who controls that? How do they use that power? Those are huge questions we have to start thinking about now.
So it's not just about the science. It's about like the ethics of it all, right?
Yeah.
What does Schneppat say we should do about all this? Like, do we just stop everything and like give up?
No, not at all. He's actually like pretty optimistic about all the good nanotech could do.
Yeah.
But he's really emphasizing this idea of like being super careful. We need to constantly think about the risks, the ethical side of things. He mentioned this precautionary principle. It's like when you're dealing with new tech, especially stuff that could be risky, you got to err on the side of caution.
Yeah. Yeah. Don't just jump in without thinking. All right. So we've covered a lot today in this deep dive, like a lot of complicated stuff. What are like the key things you think our listeners should take away from all this?
I think the biggest one is nanotech is super powerful. Like it has the potential to totally change the world, in medicine, energy, the environment, everything. But like with any powerful tool, we got to be responsible with it.
Yeah. It's not just about the cool science. It's about thinking about the consequences too. What could go wrong? What are the ethical issues? It's a lot to consider.
It is. But it's a conversation we need to have. The future of nanotech, it's something we're all going to be part of, whether we realize it or not. So, the first step is just being informed.
Well said. And on that note, I think it's time to wrap up this deep dive into nanotechnology. Thanks for joining us on this wild ride.
It's been a pleasure.
And to all our listeners out there, we'll leave you with this. Imagine a world where nanobots clean up pollution, they cure diseases, they make our lives better in ways we can't even imagine yet. But then also imagine that same tech being used to, like, control people, to spy on us in ways we can't escape. What kind of future do you want? It's something to think about as we enter this crazy new world of nanotechnology. Thanks for listening.